Hi guys. So let's start with understanding like how can we optimize the query performance in our API. So this is very important concept from interview perspective as well as when you are working in a project application. So in that scenario, in real time scenarios, whenever there is like huge number of load, huge amount of people are coming into your application, in that scenario, this type of problem can occur. Continuously, there will be a database head to fetch the data from the database or to save some data into database in a consistent basis. So that query needs to be optimized at a further level in such a way that it doesn't hamper our entire flow, like REST endpoint flow. It should not hamper that. So how can we optimize that query to our utmost performance level? So let's understand and deep dive into it step by step. Okay, so let's get started. I hope you can see my screen now. So here I will be explaining you how can you optimize your query for better API performance. Okay, so first and foremost thing is we have to use indexing process very effectively. So if you are making use of any kind of table, or you can making use of like Oracle SQL or MySQL or any kind of SQL like Postgres SQL, in that scenario, we have to make use of table and connect it with our Java REST endpoint entity classes, right? So in that scenario, whenever you are trying to fetch data from DB or saving data into database or fetching the same record multiple times, it actually needs to scan through the entire set of records, entire set of all the data in the particular database. So in that scenario, it actually slows down the performance of your query. Why? Let's suppose there are millions of records in database and all the data needs to be fetched to just get that one record. So let's suppose that particular record is present at a last record. It is at n minus one row basically. So in that scenario, it basically reduce the performance of the entire query. Why? Because that record is present at the last row. So how can we optimize that? So in that scenario, we have to make use of indexing process effectively. But how can we put that indexing? Where should we put that indexing? That also we have to understand over here. So we have to add indexes to the most frequently used column. So let's suppose we are making use of certain column which is primary key. Okay, certain column which is a foreign key to another table. Okay, and certain column needs to be used with where clause and join clause. Okay, so these are the particular columns which we have to use with where clause, and these columns which we are making use of with where and join clause, that needs to be used with for indexing purpose. Okay, not other columns, because those are not that much used. We are making use of where and join clause on those columns. That means it actually provides us the value that this particular column is to be used for the business purpose most frequently. Okay, so only those column needs to be considered for our scanning purpose. So we are not considering other columns, so it actually boosts up the performance of our queries. Okay, and we have to make use of composite indexes for queries which involves like multiple columns. Okay, so there can be a scenario there where there are multiple columns that can be considered as a set of primary key. So in that scenario, we can make use of composite indexes as well. Okay, and we have to monitor those indexes which are not being used. So let's suppose today you are making use of certain indexes which is of much use, but after 2 or 3 years, that particular index or that particular column is not being used more frequently. So you can remove it from index perspective, so that again the performance becomes more and more better. Okay, I hope you got this clarity. This is a very important concept. Indexing is very important tool in increasing the API performance and reducing the load on the database. Okay, so let's understand it, the next step. So next important thing is how can we optimize the query structure? So we should not make use of directly select star, because select star means what? You are fetching all the column data at one go. That should not be the case, right? Why you need to fetch all the records at one go, all the column data at one go? You don't need it, right? Let's suppose one table has 20 columns, 30 columns, but you just need 7 to 8 columns which are important for your business purpose. Then why you need to fetch all the column data? It's not required, right? Why you should fetch that? So in that scenario, what you can do, you can provide certain column names only for which you want the records. So for that, you need to create a separate DTO layer and you need to map it with the entity, like which all columns you need. And we have to provide the same names which we are putting for entity layer, so that it will be helpful for mapping purpose. Okay. And we have to provide the same column names which we are fetching it from database. Okay. In that way, it will increase the API performance. Second way is use joins instead of subqueries. Because whenever you are making use of subqueries, in that scenarios, you will be understanding like it will hit the innermost subquery first, then the outer subquery, then outer subquery. So if there is like 5 or 6 subqueries written, so it will go to first inner subqueries, then it will go back, then it will go back. So it will take a lot of time. But in case of join, you can join multiple tables based on the basis of that foreign key constraint. Okay, so whatever is the call column which is present as a foreign key constraint to another table, you can join on the basis of that particular column. Okay, so it actually increases the performance. Okay, so there is no inner class subqueries which has to be handled in some other way around. So join needs to be used so that it increases the API performance drastically. Then leverage database specific query hints. So if you know about this, like in the repository layer, there is one annotation called @query hints. Okay, so you can make use of that annotation. With the help of that, it actually optimizes the query performance, and it will actually tell like how many records can come and how much record is efficient to be fetched at one go. Okay, so that's why we have to leverage this database specific query hint. That feature is being provided to us in the repository layer. Okay, and we have to break larger queries into smaller manageable queries. Okay, so you should not put all the big queries in one go. Rather, you can break into small queries and try to create the relationship between the queries. Okay, so those type of queries, if you are writing, it actually increases the performance of the entire system, because everything, if you're writing in one single query, then it has to go through each and every query, right? If it is a subquery, if it is a join, if there are multiple where clauses, everything, if you are writing, let's suppose you are writing union also and also, so each and everything it will process it at every request. So you can understand like how many times it will execute all the particular levels of complexities you have implemented in the query. So, okay, so try to put it small queries. Sometimes I can understand like in pagination kind of things. In some scenarios, you need to join multiple tables, then big queries will be created. I can understand in that scenarios. But if we omit certain exceptional scenarios, then in other scenarios, we can just break it down into smaller chunks. In that way, it will increases the performance. Okay. I hope you got the clarity on this. Now let's jump on to the next thing. Yeah, so that's what I was talking about, right? We have to implement a pagination concept. You know, right? There are multiple levels of the repositories that we are aware of. First is like CRUD repository, which has normal CRUD operation. Then comes the JPA repositories, which has some batch implementation like batch update or batch delete, which is not there in CRUD operation. Then comes in between this CRUD and JPA, in between to that, there is paging and sorting repository as well. Okay. So pagination and sorting has the CRUD repository feature as well, like CRUD operation it can perform. Along with that, it will have pagination concept as well. So that pagination concept is very much important when, in which type of scenarios? In that type of scenarios when there are multiple records and all the records can't be fit into just one single page. Okay, so let's suppose one single page can accommodate at max 15 records or 10 records or 12 records. Then how can it accommodate 100 records? It will not be possible, right? So let's suppose one page can accommodate only 10 records. So I need 10 pages, and each page is including 10 records. So in that type of scenarios, we can make use of pagination concept. So it here actually what it do, if it will go to the pagination. Okay, it will be data will be stored in the page type reference. Okay, and we have to write a logic in the repository layer basically. So here if you can observe, spring data's pageable concept I'm making use of, and data will be whatever data is coming from the database, it will be stored in the page reference basically. Okay, so if you see at the query I have written, select some query I have written, then page user find all users. Okay, so page user you can took it to the next line also in the main line. Okay, so the return type of this find all users will be page of users type. Okay, so what will happen in this? In this, it will store like which particular page will contain how many records. Like first page 10 records, and second page another set of 10 records. So those type of configuration also you need to do it in your Java class. Okay, so that it accommodate those pages, like first page these many records will be there, so those accommodation will be automatically done by Spring GPA. So this is the biggest advantage which is being provided to us by Spring people. Okay, so now let's understand the next step. I hope you got a clarity on this, like how pagination helps us to improve the API performance. Okay, by optimizing our query. Then caching. This is very important concept. Okay, so let's suppose there is big billion day sale going on. Okay, some Black Friday sale going on, just like today some sale is going on, right? Black Friday sale. So in that scenario, what is going to happen? Like there are lot of records are coming, lot of hits are coming from users. And let's suppose 75 to 80% of people are targeting just one product or two products or few certain products, like 5 6 products. Then what will you do in that scenario? Will you be creating an application which is not cache friendly? Then what will happen? 75% people will be directly hitting the database, and then it will fetch the data. Can you imagine what will happen in that scenario? Like n number of people are coming and hitting that record. You can imagine in such a way that it will just disrupt the entire application. Your entire application will get crashed. 75%, you can understand how many people it becomes. 75%, let's suppose total user interface database is around 1 crore people, and out of that 75%, like around 75 lakh people in one go, it is coming and hitting those particular products database. So that many times it will have to hit the database to fetch that information. So in that scenario, what will happen? Your total application will get crashed, and then no purchases will happen after that. Then you have to modify your application, you have to modify your code, so those type of things will be there. So the best possible way to handle that scenario is implement caching mechanism. So what you can do in that scenario, there are multiple Spring cache mechanism is there, like Spring Redis cache is there. Okay, in Spring Redis cache, you can provide the configuration like which all particular records or which all type of products you want to put it in Spring Redis cache. If you put those type of products, then for those products, whenever there is first hit or multiple hits, it will identify like which kind of products are being hit multiple times, that you can set it. Okay, so once you can observe like people are looking out for what kind of products more frequently, so if you identify like these kind of products are being asked more frequently, you can just put that products record into the Redis cache. Then what will happen? As soon as after the particular threshold of time is reached, then if that product has been called multiple times, it will not hit the database. It will directly get the data from the Redis cache. So it will reduce the load on the database, which thereby increases the performance of the API. So this is the direct relation. If you reduce the load on database, automatically API performance get increases. Okay, so this we have to understand. So it is basically used for read heavy queries when we have to fetch multiple data at one go. In that scenarios, we have to implement caching mechanism. So for that, at the class level, we have to enable caching. At the rate enable caching, we have to use annotation. And then at the method level, we have to make use of at the rate cacheable. Okay. And then we have to map the data as well, so that you can identify like which kind of products you want to cache. Okay. And then normally you can send the data out of it, like find all data. So whatever data you want to fetch based upon the record, you can fetch the data back to the response. Okay, so like that we can implement our caching mechanism. Okay, so you want me to create a specific video on caching mechanism, do drop it down below. I will create a specific video on Redis cache integration with Spring Boot. Okay, so let's get started with another topic, like profile and analyze queries. So this is also one of the way to optimize your query performance. Okay, so there is a tool. Okay, so like JProfiler is a tool, YourKit is a tool, Query Statistics is a tool, Hibernate Query Statistics. So if you are making use of these tools, then we can easily identify like what type of queries are actually slowing down our performance. So let's suppose in application there are multiple repository layers. Okay, then how will you identify if this particular query is actually reducing the performance or this particular query is actually creating the problem? So it will be very problematic to understand in that perspective, right? So in that scenario, we can make use of these tools, and these tools, there will be certain UI interface, and there we can get to know like, yes, this query is creating some, it's taking more time to load the data. For these many records, this query is taking more time or this query is taking lesser time. So we can take actions accordingly once we know that which query is taking how much amount of time. So it actually plays a very crucial role in our query optimization process. Then we have to enable logging for SQL queries. So whenever you are logging, okay, then whenever there is the SQL query execution is happening, at that point of time, this logger will execute, and we can calculate the time basically, like how much time it is taking to execute that query. So there will be start time and there will be end time. Okay, so we can calculate the difference between the two time, and we can get to know like how much time that particular query is taking. And with the help of that logger, we can identify that this query is taking this much time and this query is taking that much time. In the console, you can get to know everything. Okay, or else if you are working in the real-time based projects, in that you can make use of Splunk logs. So in Splunk logs, in the prod case or in the non-prod scenario also, you can get to know like how much time it is taking to execute that queries. I hope you are getting the concept, right? Next way to optimize your query is there are different fetching strategies. Okay, so there is n plus one query problems. Okay, so we have to understand first what is n plus one query problem. So it's like a detailed topic only, it's there. Okay, so I can't cover each and everything in this particular video. It's just a video to understand, to make you understand like what are the ways to optimize your query performance. Okay, so there is one n plus one query problem is there. You can just go through it and understand like what is n plus one query problem. Okay, so there is a, it's a kind of data fetching strategy which causes this n plus one query problem. So you can understand in such a way that if there is only two record is being fetched with one query, then to fetch that extra record, we have to run the query again. So we have to run the query two times to fetch the entire set of record that we want. Okay. So at first hit of that query, only n records I will get, and then we have to run the query again to fetch that and fetch that extra record from the database. Okay. So this is the n plus one query problems that we are fetching. So it is actually happening due to inefficient data fetching strategies. So what's the solution for that? To solve this type of problem, we have to make use of either join fetch, or we have to properly optimize the lazy initialization process. Okay. So basically the most important approach is to make use of eager fetching. So if you do eager fetching, all beans will be initialized eagerly during the server runtime only. Okay. So you don't have to lazily initialize it. But in some scenarios, it will actually cause the problem. So let's suppose there are more number of beans and you don't want to initialize all of them at the server startup. Then it will create a problem, right? So we have to optimize our lazy loading feature so that it supports our on-demand data fetching strategies. Okay. So data fetching strategies needs to be optimized so that along with optimization of lazy loading feature, the data fetching strategies will also get optimized and we will get on-demand data as soon as we fetch it. Okay. So this entire structure needs to be synchronized in a proper format, and we have to write a code in such a way that a lazy loading gets optimized so that we don't have to implement the eager loading initialization process. Okay. I hope you got the concept for it. So you may be not understanding like more enough on n plus one query problem. This is a different topic basically. So you may go ahead with it to understand what is n plus one query problem, or I can create a separate video specific to n plus one query problem. So do comment it down. Then if I see comment on this, so I will create a specific video on that as well. Okay. So let's understand the next problem. Next problem is whenever we are executing many single inserts or updates, actually provides the query which is very inefficient. Okay. So whatever we are doing, like let's suppose we are doing single insertion or single updates, okay, every time. So it actually is very inefficient, right? Multiple times it is actually inserting the data one by one. Okay. So what we can do in that scenario, let's suppose there are thousands of records and lakhs of records needs to be inserted at one go. It actually creates a lot of problem to insert it one by one synchronously. Okay, in that scenario, we can make use of Spring batch mechanism. You know, right? In case of Spring, there is batch mechanism we are provided with Spring. Okay, so in that Spring batch mechanism, we can make use of JDBC template, or JPA system is also there to integrate with Spring batch, and that you can help, that it will be helpful for us to handle the bulk operations. Okay, so this is the way, like JDBC template dot batch update. So in Spring batch there is a lot of feature basically. Okay, so I've recently created video on Spring batch. You can go through that. I have told you like how can you write read operation, write operation method, how can you create jobs in that, how can you create multiple steps, like how jobs are related with steps, how read write operations are related. These all things are interlinked with each other. So how those things are working, okay, how we are saving data into database from the file, how we are loading file into database, those kind of things we have already discussed in Spring batch video. You can just go through that, you will get the idea on this. Okay, so in just one liner, I'm telling you how will you implement the Spring batch part. So you can write JDBC template or batch update. With the help of that, what you can do, you can update entire set of records in batch. It's not one by one. So it's like multiple threads are working parallelly and it is updating the data into database. Okay. So the actually Spring batch reduces a lot of time and it reduces a lot of efforts on database as well. In hence, it increases the API performance as well. I hope you are getting the concepts. Okay. Next problem. Then there is connection pooling problem. Okay. So whenever you can see like data connection, database connection is very inefficient. which actually leads to latency kind of problem. Okay, so it is taking a lot of time to give the response. Okay, so what, how to resolve this kind of problem? So we have to configure a robust connection pool using this Hikari pool. Hikari pool is the default configuration pool which has been provided to us by Spring Boot. Okay, so these configurations are being given to us by default in application.properties. So if you can write this like spring.data source Hikari, like maximum pool size is of 10, minimum pool size ideally should be 2, and idle timeout will be around 30 seconds. Okay, so if you provide this default configuration, if you can provide like this, then it will optimize the entire connection pooling problem. Okay, in that scenario, what will happen? Then it will not create the latency problems. Okay, and database connections will become very much efficient. And then as soon as database connection becomes efficient, latency problem will be reduced, and automatically API performance will increase, because query gets good performance, that is fine, but the data should get respond back properly, right? If data only not getting responded to the request properly, then what's the use of improving the query? There is no use, right? If query is being improved, then there should not be any latency. So that should be kept in mind. And for that purpose, proper optimization of connection pooling is required. I hope you got the clarity on this. Next concept, we have to tune the Hibernate. Okay, so there are a lot of configurations we are doing in Hibernate, right? And actually, that Hibernate configuration actually slows down our query performance. Okay, there are a lot of configurations we are doing. We are doing show SQL query equal to true. We are showing like what's a timeout, and whatever type of queries we are writing in that also we are customizing it. Okay, we are providing all sort of details like username, ID, password, and all sort of details we are putting. And whenever we are in need of certain type of data, that also we need to provide the configuration for that. And we are providing caching also. Okay, so the default caching, so what's the solution for this? How can we remove this problem of Hibernate configuration? Okay, in that case we have to make use of caching. Okay, so default configuration is first level caching basically. So in that case, first level caching can resolve the problem with respect to, like, if there is normal simple data or small amount of data is being hit multiple times, that is fine. But if there is like large number of database records are present and it requires a lot of Hibernate configuration, in that scenario it actually slows down the query performance. So for that sake, we have to enable the second level caching, which can be resolved with Redis cache or cache. Okay, so for that we have to apply the Hibernate JDBC batch size key. Okay, that should be applied as a key, and we have to provide the particular batch size, like how many size of your batch should be used for entire caching purpose. Okay, so that will help you to enable all the processes to be done in a very lesser time, because a lot of processes can be resolved in batches. Okay, if there are thousands of records, then 100 records will be done in batches, let's suppose. I'm just giving example. So it will automatically increase the performance of API. Okay, and we have to disable the auto flush. So whenever you are reading it, a heavy transaction, there is a read heavy transaction. Okay, so I've told you, like, if you are buying iPhone, like 80% of the people are buying iPhone in big billion day sale, then what will happen? There is a read heavy transaction in that scenario. So every time if you are auto flushing it, okay, once you have done with the buying purpose, you are auto flushing it, that data is being removed. Again, that same product has been hit. Like, I want the data for this particular iPhone. Again, it will hit the database. Again, it will auto flush. So every time it is auto flushing, at every and each instant it is hitting the database. Okay, so that is creating a problem. So we have to disable auto flushing. That doesn't mean that auto flushing is not good. Auto flushing is good in that scenario when number of DB hits are lesser as compared to more amount of DB hits. If there are more amount of DB hits, then auto flushing needs to be reduced a bit. Okay, so this is the thing that we have to understand. So let's understand the next problem. Next problem is whenever there is synchronized queries are being used. Okay, so queries are being called one by one, let's suppose. Okay, so if there are threads running, in that scenario, if there is synchronous queries are running, like one query is running, then second query is running, then third query is running, it can actually block the execution of thread. Okay, so it actually creates a problem. So let's suppose one of the method or one of the process actually takes a lot of time to give the response. In that scenario, it will actually block the thread, because the synchronized query is written for that, right? So it will call the method, it will not give the response in that particular time frame. So if we are not getting the response in that particular time frame, then it will give some gateway timeout issue, okay, as a response. So how can we resolve that problem? In that type of problem, we can make use of @async annotation is there, which is asynchronous form of programming. Okay, so asynchronous execution of the particular task is being handled with @async annotation, which is being written over a particular method, or you can provide it over a particular class. So it depends like where you are trying to put it. So we are providing non-critical queries with @async in Spring, so that it will handle, Spring will able to understand that this particular method can be running parallelly, which is not dependent upon the current flow of execution. So what will happen in that scenario? Whenever the request is being hit from UI or from Postman or from any region, in that scenario, it will go to through the flow. All the flow will get executed, and during that flow of execution, it will not go through this particular method, because this particular method is being marked with @async. So it will provide information to Spring Boot. Yes, this particular method is marked with @async, so it will execute its with its own time. Okay, it will take its own time to get the data response back. So I will not wait for this method's execution to get completed, and I will allow the rest of the flow to complete first. So as soon as the entire flow gets completed, during that time, if this method's flow is being over, or it is giving me the response, it's fine. Or else it will move the entire response and it will give the response based upon the other flows. It will not consider the result of this particular methods, whatever method is written. And automatically we'll see parallelly in the background, this method flow will be keep on going. And then after some time, you will get the response of this method. So this is basically the importance of @async. Basically, for this, you don't have to wait like how much time it will take for this method to give the response. You don't have to wait during that for that much period of time. It will give the data by taking its own time. So that is the major advantage of @async, because it runs parallelly in an asynchronous fashion. Okay, so in basically it is used in multi-threaded environment in executor framework type of scenarios. So here you can see I've written it over @async over completable future, where it is accepting list of user of completable future type. Okay, so basically we are fetching the user from the database in an asynchronous fashion. So in database it can have like millions of records, right? And to fetch millions of records, it will take a lot of time. So in one flow, it may not be able to fetch the entire set of records within the peculiar time frame which has been assigned, like 2 seconds or 3 seconds. It may take 2-3 seconds more depending upon number of records in database. So in that scenarios, we are putting @async, like if we are knowing that this particular method will take more time to give the response. Okay, I hope you got the entire clarity on this. Now let's understand the next step. So the next problem is we are not able to understand the database health. Okay, like what's the database state? So whether its state is up or state is down, or the application state is up or application state is down. So if you're not aware of the health of the application or the health of the database, in that scenario, it actually impacts the optimization. Okay, it impacts the API performance as well as the query performance as well. So this lack of insights into database health, it actually impacts the optimization. So for that, there's a solution for that. What's the solution? You know, right? Health means actuator. So Spring Actuator is being designed in such a way that it will actually check the health metrics basically. What's the current health metrics of your application, Spring application? Okay. So if it is returning me up, that means its health is good. If it is returning me down, that means it will check based upon certain metrics, obviously. So based upon that, it will check and it will give the response whether it's up or down. If it's up, that means health is good. If it's down, that means health is bad. Like that, it is being kept for monitoring purpose specifically. So this actually sets up the monitor. It actually alerts. It sets up the entire alert so that it slows queries. Okay. So whenever you will see like there is a query problem, mistake, query is taking a lot of time to give the response, it actually sets up the alert in that scenarios, and it will give you the alert. It will give you the alert in the form of notification. There can be notification message kind of thing enabled in your API. Okay, or there is an email kind of thing being enabled in your application in such a way that it has been integrated. Email system has been integrated, and let's suppose some app dynamic alert has been integrated in such a way that it will continuously monitor, and wherever it will see like this particular query is taking a lot of time to give the response, it will send the alert in the form of either notification, in the form of mail, message, or email. It totally depends like how are you integrating it with your API. So in that scenario, it will reduce the latency problem, and then it will increase the optimization basically. And as soon as it improves the performance, it will improve the entire structure of your API optimization. Okay, so API optimization depends upon lot of things. It depends upon query. It depends upon how are you writing the entire structure of your API. How are you optimizing your query? Okay, this alert process. These all things combined will help you to find out like which all queries are not good, which are not properly written, and which can be optimized more. So we have to continuously monitor our database performance. That is very much important. Okay. Next is this. We have to optimize the data fetching logic as well. So whenever you are seeing like there are a lot of data you are going to fetch from the database, and there are multiple columns and we don't want to fetch multiple columns. So you can implement projections with JPA as well. Okay. To fetch only those data which we want. So this is an example like user summary interface is there. Within that is name and email. Okay. So within user summary class, there can be user summary database. Basically, you can have like 20 columns, 30 columns, but you want only 2 or 3 columns. I'm giving just example. Okay. Then in that scenario, what you have to do, you can implement projections as well, or you can create one separate DTO class. You can map it with the entity and you can set the data with getter setter. Any way you can do, but you should be knowing the thing like how to do and why we are doing that. That is more important. Okay. So here, if you observe, I've written at the query. We are just selecting those columns which we needed from that particular table. Okay. And then we are storing it in list of user summary, like it can have n number of records in database, right? But we want only do 2 columns, not all the columns, 20, 30 columns. So in that scenario, JPA projection will be helpful in optimizing the data fetching logic. So this way it will optimize your query performance and the API performance will be increasing drastically. Okay. So this is the problem that we have solved. So this is the end of it, guys. I hope you got the clarity. Like there are a number of ways we have discussed to optimize our query. Okay. So increasing the optimization of query will help you to increase the API performance like this. Okay. So this is the important thing that I wanted to discuss with you all. I hope you liked the video and you like the way that I have presented to you this entire concept. So we'll be seeing you in the next set of video with next set of concept. Till then, it's Devjit Roy signing off. Bye bye.